Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. So, what we left uh, from where we left was exercise 9.1, which was all about sequence search and sets. So, we have already covered exercise 9.1, and just to revise you, I may tell you that what was term to term rule. Term to term rule. TTR. Okay, it is term to term rule. For example, I have two here and two something I have to add is, let us say I add 6 over here. So 2 plus 6 is 8, 8 plus 6 is 8 plus 6 is how much? 14, 20, 26. So you see that I have written a regular sequence. In what sequence I have written is, you just see that what is the sequence over here. Now this is the previous term, this is the following term. So when you add an equal amount to the previous term, you get at the following term. Now this is the previous term, you get the same amount, difference, the same difference, which was over here. You add here, you add here, you add here, and you always be getting the next term. For example, you see that there is a difference of 6. So what we have done is we have added 6 in the previous term to get the following term. So again, we have, now this is the previous term, this is the following term. So we have added 6 in this term, and so forth. You see that all the differences, all the increments are 6. Or if I reverse it, you just can say that this is the previous term and this is the following term. If I am going in reverse order, so I am subtracting 6 from each. Now this is the term to term rule. Now this is term to term rule. And for example, if this is 1, if this is 1, now this was for the addition, term to term rule for addition or subtraction, and this is for multiplication. Okay, now this is if I multiply this with but for example I do it with 2. Okay, now 2 times 4, and 4 2 times 8, 4 8 2 times 16, 8 16 2 times 32. You see that the increment is now multiplying with 2, multiplying with 2, multiplied with 2. Now this is again multiplied with 2, again multiplied with 2. Okay, you see that each difference or each increment is being multiplying with 2, 2, 2, and so on and so forth. Similarly, if there is another example, for example, I have 1, I just divide it with for the division, term to term rule for the multiplication, term to term for the addition, for term to term rule for division. It is like this: 1 by 2, 1 by 4, 1 by 8, and so on and so forth. Now what is we are doing? We are doing each term, each previous term with 2. We are dividing each previous term with 2. Now when I divided this term with 2, we get this. You see that when dividing it with 2, divided it with 2, you get this. Okay, divided with 2. I always do when there is a 3-storied building, just bring it over here. 1 upon 4. Okay, now similarly here 1 upon 8 and 1 upon 16. So these are the term to term rules. Okay, now uh, going forward, a little forward, we now you see that there was I just erased, what was it, 2 8 14 20 and 26, I think. Okay, now you see this is the fifth term over here. This is the fourth term. This is third term. This now what if we want to point out the specific order, or if we want to specific, we want to know about the term which is at 100th place. What would be at 50th place? Say 100 is far more away. What will the number at 50th place? Who can tell me? You? No? Okay. there is one way. Just keep on adding 6, keep on adding 6, keep on adding 6 for the 50th term, and just fill this board. No, this is not the way of doing it. We have a certain formula, and will formulate it by ourselves. We'll formulate it by ourselves, that how will we find the 50th term, 40th term, 48th term, 95th term, 100th term, or even more bigger terms. We can formulate where we get, and that term is called the nth term. Nth term. Nth term. That is called nth term. So let me formulate that nth term. Now, so there are term and terms. Now there are how many terms? Numbers, term number. So let me do it term number. Term number is equal to 1, 2, 3, 4, 5. 1, in our case, what was it? Let me again write it. 2, 8, 14, 20. Now this, you see that this is the first term, second term, third term, fourth term. And similarly, we have just made a table of like this: 1, 2, 3, 4, and just do it like this. Make it a little smarter. I should have a smart board instead of this. So our first number, term. Now this is another example. 5. Our first number is 5. Second number is 8. Third number is 11, and maybe 14. And fifth number is 17. Okay, include it in the table. Okay, now you see that term number is 1. Just in our example, the first number was 2. Now in this example, the first number is 5, second number is 8, third number is 11. And what is the difference between them? What is the difference between them? What is the increment between them? The increment is, you see, that 5 plus 3 gives us 8. 5 plus 3 gives us 8. 8 plus 3 gives us 11, and so on and so forth. So you can see the difference, that it is the term which is being increased by 3 numbers. 3 numbers. Okay. Now, for example, if I do it like in another fashion. Now this is the our basic example. This is the our basic example. So what we do? This was term which was being added with 3. Now if I multiply it with 3, now what was, you see that this is the uh, 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 adding with 3. If I multiply it with 3, if I multiply it with 3, what will happen? You see that it will become 3 1 times 3. Now my dear students, there were some external noise, so I stopped for a while. So if I multiply it with 3, 3 times 3, now this is what we call it 3 1 times 3, 3 2 times 6, 3 times 9, 4 times 3 4 times 12, and 5 times 15. Okay, now this is our second term. Now what we are doing is we are multiplying. Now this is called n. This is called, what is this? Term number is n. Term number, as I told you, want to find the nth term. As I told you, when I want to find the nth term. So now I am step by step building a formula, formulating a formula. You see that what I have done is I have multiplied 3 with n. I have multiplied 3 with each n. 3, 6, 9. So can I say that this is 3n? Can I say that this is 3n? Yes, of course I can say it is 3n. So One step more forward. If you just compare the two, now this is again a table. I am missing a smart board. Wow, I am missing a smart board. You see that this is 3, this is 5. Just compare them. Just compare them. You see that this is 3, this is 5, this is 6, this is 8, this is 9, this is 11, 12, 14, 15, 17. Is there any sequence in between the two? Is there any sequence? Yes, I can find a sequence in between the two, and this is that for each value, for each term, that is 1, 2, 3, 4, 5, for each term, you are adding 2. You are adding 2. 6 plus 2, 8, 3 plus 2, 5, 9 plus 2, 8, 11, and 12, 14, and 15, 17. That means it means that for each term, 3 and term. For each 3 and term, for term, therefore term which was added in equally was that we have, now we are adding 3 plus 2 is 5, 6 plus 2 is 8, and so on and so forth. Okay. Now, what we have done is 3n plus 2. Here, what we have done is 3n plus 2. For this first term, we have done 3n plus 2, 3n plus 2, 3n plus 2. Okay. For each. Now, this is called position to term rule. Now, this is what is called? This is called position to term rule. To term rule. This is called position to term rule. One step more forward. We are going step by step now. We are going step by step. Now, what is this? I just used a term that was nth term. Now, this is the nth term. This is the nth term. Okay. So, this is the nth term. And now, what I told you, we want to find the 50th term. We want to find 48th term. How will we get? Now, you see that this is the n, 2, 3, 4, 5. For example, this is 44th term now. This is 44th term. How will you find the 44th term? Just because this is number n. This is 44, 43, 42, 41. Okay. Now that means n is 44 over here. N is 44 over here. 44 I read 44. Okay. So what is our 44 term? That is 3 multiplied 4 is 12. 3 multiplied 4 is 12, and 1 13, plus 2 is equal to 134. So this is your nth term, which was supposed to be 44th term. 44th. Understood my point? So how we find, just in one line, rather to fill the board, first term, second term, third term, fourth term, and here you get the 44th term. I just found it in 2 lines. So this is how we find the nth term. Now let me do one example now. Worked example, page number 257, and the book is, which book we are going to study now. This is the book, third edition. Okay. Mathematics Core and Extended Course Note. Karen Morrison and Nick Hamshaw. Cambridge Press University, Cambridge IGCSE, trademark Mathematics Core and Extended. Okay. So let us continue our lecture from where I left. Well, students, just finished example number 1. which was very easy, and it was explained in terms of term-to-term rules. And uh, we formulated a specific formula for that. That was 3n plus 2. Okay, that was 3n plus 2. But you will see how we are formulating another formula instead of this. So there is an example 2, work example 2, and that the page is example 2, page is 257 of the book I just showed you. Okay, now what does it say? Find the general rule for the nth term of the sequence. Though this has been explained very beautifully in your book, but let me explain in my own words. So this sequence is given to you: 2, 6, 10, 14, 18, 22, and 26. Okay, now what is the question here? The question is A. Question is, find the general rule for the nth term in this equation, in this sequence. So, my dear students, you see that what we are doing here is we are just adding some constant number to this sequence in each step. We are adding some constant number. For example, if you subtract the later from the previous, the later from the previous, later from the previous, and so on and so forth, you will get 4 each time. The difference you will get is 4. If you just see that you add 2 plus 4 is 6, 6 plus 4 is 10, and 10 plus 4 is, and so on and so forth. Now this is the general rule, that how this sequence has been built. How this sequence has been built. Now it means that if I say that the 4 is the difference, and if I just tabulate it, in this form. Okay, now there are 3 rows. These are rows and these are columns. Columns are 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Okay, now we'll write n over here. As previous, you see that 1, 2, 3. Now this is the position 4, 5, 6, 7. And I told you uh, how to calculate the nth term. So, my dear students, so let me write the terms now. What are the terms? You see, first term is 2, second is 6, and 10, and 14, 18, 22, and 26. Okay, so these terms, I fit these terms, manipulated these terms in this term row and respective columns. Now, what is the, it is 4 and n. 4n, that means 4 multiplied by n. 4n. N is what? N is here. 4 multiplied. No, you are getting the multiples of it. Yeah, 4 multiplied by 1 is equal to 4. Okay. 4 and 4 multiplied by 2 is 8, and so forth. 12 and 4, 4, 16, 4, 20, and 4, 24, and 28. So we got these. Now you see that each term, this one, is less than the 4n term. This term is less than 4n term. That means that we are getting 4n minus 2 if we want to find the term. If we want to find the term, we have to subtract minus, so we have to subtract 2 from 4n. Wherever the case may be. You see here 4n is 20. If you subtract 2, you will get 18. So this is the general rule and answer for number 1 is. What was the general rule? Yes, this is the general rule we have constructed in this formula. Now this example is very much important. If you just understand this example, you will do the question of exercise by your own, because uh, this example has been explained very much. So we want to find the 40th term in part B. In part B, what we have to find is 40th term. 40th term, how will we find the 40th term? Of course, n will be 40. N will be 40. For example, now you see that this is 30. For example, this is 39, this is 40, and 41, 42, 43, and similarly 8, 38, 37. Now this is the table. I've gone advanced, very much advanced. But I don't even know what will be here. But I still know what will come over here. I don't know what will be here, but I still know what will come over here. And here we will get, and here we will get. When we say that is 4n, 4 multiplied by 4, 16, and it is 160. Okay, it is 160 in the 40th column. Okay, now this is 160. Now, what was the general rule? This was the general rule. This was the general rule. So we have uh, calculated. We have calculated 4n instead of the term which was required. Now this term was required. This was not required. Okay. So how will we find this term? We'll just manipulate these figures in this and we'll get the term. Now this 4n is 160 minus 2, that is equal to 158. Now that means this term, the 40th term or whatsoever is asked is 158. Is 158. So my dear students, you see that how we find by our own general rule the 40th term. The 40th. We'll be inshallah formulating a specific formula for this to find the nth terms. Okay, don't worry. Now about C, I'll keep on. I'll keep. Now let me make this table back to its original position. Now this was 1, 2, 3, 4, 5, 6, 7. So this was 1, 2, 3, 4, 5, 6, 7. This was 4 times 16. Okay. 4 times 16 will come over here. Okay. And this was the distance 4. It was 14. Okay. Now it is correct. The table has been made to its original position. Now what is this? Explain how to know the number 50, the sequence, and work out which is its position is. Now we have to find whether or not. Whether or not. No. Explain how you do know that 50. Now 50 is given to us. Number 50 is given. And we are asked that at which number it will come. 50. At which number it will come. And the part is, and work out which position is it, and how you know that the number 50 is in the sequence. Now there are two questions in part C. In part C, there are two questions that 50. How do you know that 50 is in this sequence? 50 is in this sequence. And number two, 50 is in this sequence and at what number? At what number? And at what number? If it is there, if 50 is in this sequence, so if it is there, so what is the number of the term? What is the number of the term? Okay, so we have to find it. So this formula which we have just formulated will be used here as well. Now I'll write here because I don't want to erase the table. Okay. Now 4n minus 2 was our formula here, and now it is equal to 50. 4n minus 2, because if I go back to any example, for example this one, if you see 4n was 20, 4n was 20 and minus 2 was 18. So we got the fifth term. So similarly, we'll find the 50. So we are given the number 50 now. So it will become 4n is equal to 52. When this minus 2 will jump over here, it will be positive. So how 4 1 times and 4 3 times and 4 3 times. So it means that it at 13th place, at 13th place, so at 13th place, for example, this is the 13th place, 11, 12, 13. At 13th place, 50 will appear. Yes, this is included, 50 is included in this sequence. 50 is included in this sequence. Where was the sequence? This was the sequence. Yes, the answer is yes, 50 is there in the sequence. And at what place? It is at the 13th place. It is at the 13th place. There are two answers. For, of course, there was two questions, so there were two answers. Explain how you know that number is not in sequence. Now there is a number given to you. There is a number given to you, which is D part T. Number is 125. Now it is asked to you that how will you know that this is not in the sequence. Number 1 point, you see that each of the number may be at 13th position, and 40th position. We also found the 40th position. Which was that? That was 158, I think. Yes, 158. This was the 40th, at the 40th place. It was at the 40th place, 100. You see that at the 13th place, at the 7th place, 3rd place, second place, first place, all are even. All numbers are even. Not a single number is odd. Not a single number is odd. Now this is the logical answer for this. Because it is odd number. So it cannot exist in this sequence. It cannot exist in this sequence. And number 2 is, we'll use the formula which was 4n minus 2. Okay. For example, now 4n minus 2. Again we'll use this formula 4n minus 2. Now suppose the number is there in the, yes, of course, this is our hypothesis. The number is in the sequence, that is 120. It is in the sequence. Now just assume that Just assume that number is in the sequence. So we have to prove it that it is in the sequence. That it is in the sequence. So again, what we do, 4n is equal to, just will jump over here, it will become 127. So n is equal to 127 divided by 4. Divided by 4. Now you see that this is not divisible by 4 completely. This is not divisible by 4. The answer will come in points. So we don't want to the answer in points. Therefore, you see that it is not completely divisible by 4. So the number does not exist in this sequence. This number does not exist in this sequence. Now this is complete. First four parts of this question are complete. Now we'll finish this work and ample, because this example is very much important, as I told you. Now stepping forward, find an expression of an term of the sequence 2, 5, 10. Okay, now the sequence has been changed now. The sequence has been changed for the question. Show how now if we are given, if I erase this, I think it will be of no harm if I erase it. So now new sequence is given to elaborate it further, and that is 2, 5, 2, 5, 10, 17, 26. 10, 17 and 26. So this new sequence is given. You say that if you subtract the the if you subtract the following from the previous, what will you get? Or you just add 2 from the previous to the following. It will be 3 plus 3. Plus 3 is your answer for the common difference. So common difference is denoted by CD. Common difference is equal to, we have to find the common difference. We have to find the common difference if it comes there. So 5 plus 5. Oh, what happened here? What happened here? It is plus 5. It is plus 7. It is plus 6 and 3, 9. And it will be going further like this. You see that there is no common difference in between that. There is no common difference in between them. First it came 3, then 5, then 7, then 9. It is obvious that it is not the common difference. But let it, let me take it the second difference. Now this was the first common difference. First common difference is not there. The first common difference does not exist here. First common difference does not exist. Now just take the second common difference. Now our sequence is the red one, not the black one. Okay, you see the common difference is 2 over here. Common difference is 2 over here. And common difference is 2 over here. Okay, you see that we have come to an answer that there is a common difference. There exists a common difference. But this common difference is called the second common difference. Second CD. Okay. This is not the compact list. Okay. This is second common difference. Now, what does it mean? That it means that the sequence is quadratic. Sequence is quadratic. Quadratic. I think I have told you what is quadratic equation. Now this is quadratic equation. This is quadratic, and so this sequence is also quadratic. So this is quadratic. And now let me make tabulate it. Now let me tabulate it. Now same three rows, 1, 2, 3 rows. N is there, term is there, and since I say it that it is the square, so it is be like this now. So first term is first and 2, and n square is 1, because anything raised to power 1 is 1. Okay, now second term is 5, and n square will be 4. N square will be 4, and similarly 3, 10, 9, 4, 17, n square 16, 5, 26, and 25. The rest are not there. Okay, let it be inactive. So this is our n, 1, 2, 3, 4, 5. This is the term 2, 5, 10, 17, 26. And n square is, of course, when you scare it, it will become 1, 4, 9, 16, and 25. Okay. Now each term is 1 greater than. You see that each term is 1 greater than the value of n square plus 1. How? You see that this is n square, and this is 2. So that means n square plus 1 is appearing over here. Let me check it on the second term. Just try it on this term also. Okay. N square is what? 4. N square is 4, but the term is 5. Okay. It is. This also satisfies here. This also satisfies here. This also satisfies here, and this also satisfies here. Everywhere. This will satisfy everywhere. Okay. Even at this point. Now, this is all credit sequence has constant second difference. Now, this you see when this thing appears. Just I told you ax square plus bx plus c. You see that this is the quadratic equation. So when the quadratic sequence appears, thus you will not find the first common difference. You will find the second common difference in between them. Now one point more. This was quadratic equation. If you have third degree equation, that means cubic equation, then you will not find the first common difference, you will not find the second common difference, but you will find the third common difference. Okay, you will find the third common difference. So I hope that you would have understood this point. And then, so I must leave this lecture here, because otherwise the length of the lecture will be too long. So you will get monotonous and you will not watch it properly. You'll just skip and skip and skip and forward and forward and forward. So it's time to see you. Goodbye. Allah Hafiz.